Okay. Hello everyone. Today we are going to continue the topic about the motion in the straight line. And yeah, this is the previous topic about the scalar and vector. And you have to remember that a vector, it has a magnitude and a direction. And scalar, it's only magnitude but doesn't have a direction. And for example, in physics, quantities, we have some kind like displacement as wait. So for example, velocity, displacement. Okay, this is the example of the vector in physical quantities. But in scalar, for example, we have temperature, and then what else? So the negative component of a vector, for example, if I have the velocity is minus 15 meter per second, okay, that means the negative sign is a direction of the vector point, okay. So the negative sign in the vector, uh, it means the direction of the vector point. So for example, minus means to the left, okay. So the object is moved 15 meter per second to the left, okay. And scalar, yeah, scalar in physical quantities, it doesn't need a direction. For example, temperature. And what if we have like a temperature minus 15 degree Celsius? Okay, this minus, it doesn't mean the direction, but the negative value of a scalar, this is describe how much it below zero. So the temperature is 15 degrees Celsius below zero. So it's totally different meaning, right? Okay. Now, yeah, this is the multiplying and dividing a vector. We already learned about it, how to multiplying a vector by a vector and a scalar. We have scalar product. Do you remember? A dot B, A vector dot B vector. And for the vector product, we have vector A cross vector B. Okay, so let's we check your understanding. So in this statement, we want to find which statement is involves a vector. So A, I walk 2 miles along the beach. Okay, there is no direction, so this is still scalar. But in the second statement, so I walk 2 miles due north. This north, this is a direction of the walking. So this is a vector. Okay, I jump off a cliff and hit the water, traveling at 70 miles per hour. So this is the velocity actually, but because there is no direction, so it's still scalar. And at the statement, we have this straight down word. That means this is the direction of the velocity. So this is a vector. Okay, and look, this is about your bank account. My bank account shows a negative balance. This negative, it doesn't mean it is a direction. No, because your account is a scalar. Of course, your money is scalar, right? You don't need a direction of your money. So this minus, that means your account is $25 below zero. Okay, do you see the difference? And yeah, now we are going to learn about mechanic. So mechanic, this is a branch of physics that study of motion object. And in mechanic, we have kinematic and dynamic. So in kinematic, we do not x, y, the object move. So we just consider that the object is moving with the velocity, certain velocity, certain position, but no no force. Okay, but in dynamic, we consider about the force. Okay, and it answer why the object can move. Okay, so yeah, last day, I think in the Monday, we already learned the difference between displacement and distance. So yeah, displacement is defined as the change of an object position. So in displacement, we just need to find the initial position. So for example, this is 0.0, and this is last position. So for example, if a person walks 70 meters east to the east, okay, and then 30 meters to the west, so the displacement is only at the last position minus initial position. So this is 40 meters. Okay, this is for displacement because displacement is a vector. Remember about that. Okay, but if you want to find the distance, okay, the distance is the total distance traveled. So uh, we move 70 meters and 30 meters. So the total is 100 meter. So 100 meter is the distance. So it's total distance. Okay, so do you find the difference between the displacement and distance in this case? Okay, so just remember this um, definition. Okay, displacement displacement is equal to the last position minus the initial position. Okay, yeah, this is the example. I think it's quite easy. So for example, a particle moves along a line from x1 5 meter I. So don't forget about the I sign. This is unit vector. That means the object is moved in x-axis and it moves to x2. This is 12 meter. So the displacement is, yeah, it's really easy. 12 minus 5 is 7. Okay, and this is from 12 to 5. So if we have like Cartesian, so this is 0, and a particle is moved from 12 meter, okay, to 5 meter. So it moved to the right. Yeah, you can just simply uh subtract delta v, sorry, not delta v, delta x is equal to x2 minus x1. So it should be 12i minus 5i. So it's 7i minus, wait, sorry, I think I made a mistake. It should be 5 minus 12. 5i minus 12i. So this is minus 7i. That means the object is moved to the right, to the left, sorry, to the left that direction with a magnitude 7. Uh, okay, this is also, I think it's easy. So start at 5, move to 2, so like this, and return to 5. So because it returns to the same initial position, the displacement is 0. Okay, I think it's quite easy. Okay, so this is the third example. I think you need to exercise yourself. So please solve this problem, yeah. Uh, and now we're going to the average velocity. So velocity is a vector as well. Velocity is with speed. If you want to find the speed, you can, you know, this is distance over time. But if you want to find a velocity, it should be displacement over time. Okay, so the average velocity is equal to delta x. Delta x is the displacement over elapsed time, delta t. Okay, it's still on same axis, so it's one dimensional, so it's still easy. Okay, and the unit of the average velocity is meter per second. Okay, so this is an example. The car is first travel from left to the right and covers a distance of 1,609 meter. Okay, it's 1 mile in a time of 4.774 second. And this is the reverse direction. So this is the same distance in 4.695 second. Okay, and we need to determine the average velocity for each run. So it's very easy. The delta x for the first case. So remember that uh, average velocity is equal to delta x over delta t. And the delta x is from 0 to 609 over 4.740 So this is the answer. Yeah, this is the same case with the second example. But in the second example, the direction is minus. Okay, minus, that means it has a different direction. Okay, in first direction. And we can also find the average velocity in the graph. Yeah, for example, this is the graph between t0 until 2.5 second. And the problem is you need to find the average velocity from t1 is 1 second to t2, 1.5 seconds. So in this interval, okay. So yeah, it's still easy, right? This is x1, this is x2, initial position, and this is the last position. And this is initial time, t1, and this is t2. Okay, so if you want to find the average velocity, so we can just you know find the delta x, the change of its position, and delta t. So in this case, we have x2 minus x1 over t2 minus t1. So x2 is minus 0.22 minus x1 is still minus 1.24, okay, over 1.5 minus 1, right? So we have, okay, because this minus time minus is plus, so we have 1.02 meter over 0.5 second. And the result is 2.04 meter per second. So it's quite easy, right, to find the average velocity. Okay, so average speed is yeah, can describe how fast a particle moves, but the difference between displacement and the distance, right? Distance is a scalar, displacement is a vector. So if the average velocity, that means this is delta displacement over time, but in average speed, we have total distance over time, and average speed is a scalar quantity. Okay. Yeah, so you can check your understanding. Please answer the questions and write it on your book, and you can collect it on LMS. Okay, so yeah, we have so much example here. I think it's not difficult, really. It's not difficult. It's easy. This is about average velocity and average speed. If you really understand about what is velocity and what is speed, yeah, I think this question is not really hard for you. And next, instantaneous velocity and speed. So, yeah, it's related to the slope of a graph. Yeah, it's a moment in time. So, if you want to find the instantaneous velocity and speed, you need to find the first derivative from the displacement of a time. Okay, and uh, yeah, for example, okay, so what is the instantaneous speed? Yeah, this is only speed, the speed in exact time. For example, if I want to know what is the speed at t is 5 seconds, what is the speed in your motorcycle at 5 seconds? Okay, so that is instantaneous velocity. Okay, and yeah, you see, this is we have like four equations. Okay, and we want to find the velocity, instantaneous velocity. So at the previous, we have learned that the instantaneous velocity, okay, is equal to the first derivative of x, okay, over t. So for the first case, you know, we have the instantaneous velocity is equal to derivative of uh, 3 okay, you can just write it like this, 3t minus 2 meter per second. Okay, and the result is 3 meter per second. Okay, and from the second we will have uh v is equal to minus 8t minus 8t, right? Do you know how to derive a question, an equation? And for the third, it's the same. So v is equal to 8 meter per second. Okay, 8 meter per second minus, sorry. And this is 0. Because it's constant, so the derivative of the constant is 0. So the question is, in which situation is the velocity of the particle constant? So in this situation, in the third and in the first, you know, third is no, sorry. Still have t, right? Okay, it's only at the first case because it doesn't has a variable t, so it's constant 3 meter per second all the time. All the time, I mean. In which is the vector pointing in the negative x direction. Yeah, this is all the negative things. It's yeah, in the second and the third case, this is the vector pointing in the negative x direction because the result is negative. Okay. Yeah, now is we'll learn about acceleration. So if the particle's velocity change, for example, if you start to move with your bicycle, okay, the initial velocity is 0, right? Okay, the first velocity is 0, and then when you make it move, okay, that means there is an acceleration, because if there is an acceleration, So the particle's velocity will change. Okay. So this is how, uh, if we want to find the average acceleration, yeah, it's simple. We can just find the change in velocity over elapsed time. Okay. And the unit is meter per second squared. And also we have instantaneous acceleration. That this is the first derivative of the velocity. Okay, first derivative of the velocity. So from the x, we can find instantaneous velocity. The first derivative is instantaneous velocity, and the first derivative from the velocity is acceleration. Okay, and this is free fall. Free fall. This is special case because in free fall we have a special acceleration. You know, gravity. The gravity, yeah, it's 9.8 meter per second square, but actually it's not this exact. But yeah, you can see this is an average value. Yeah, and yeah, this is a conceptual questions. So for your attendance, please solve this problem. We have 5 problems. Okay, and I think you don't need to calculate anything, right? Because all of them is like a understanding problem. So yeah, please put your answer in the WhatsApp group, and we can discuss after that. Okay, so this is the end of the explanation. Thank you very much. See you next week. Bye bye.